So let's investigate inverse trig functions. Chapter 7. First, let's recall the basic sine, cosine, and tangent graphs. This might come in handy when you're trying to do inverses. So first of all, you have to remember that a sine graph starts at the origin, goes up, down, down, up, and is negative this way. A cosine graph starts at a maximum, goes down, down, up, up. And the basic tangent graph starts with a point on the origin and goes like this. He's got asymptotes on either side, and then he'll start to repeat, but there's one full tangent period. Okay, inverse means to go backwards. To go backwards. So what we are going to start doing this chapter is solving inverse functions by going backwards. Okay, so we state the angle as the answer. All right, let me show you how this could look. It could look a couple of ways. First of all, sine inverse is written sine inverse of x. And then that equals theta, and theta is the angle. So I'm not going to say find sine of pi over 2. I'm going to say the sine is something. You have to tell me the angle. Another way to write this would be to say arc sine of x, and then you state the angle. Okay, same thing for cosine. Cosine inverse looks like that of x. That's where you put the value, and your answer is the angle. That is equivalent to saying arc cosine of x equals theta. These are the same. So if you don't like one version, you could always switch to the other. Tangent inverse of x, the answer is going to be theta, some sort of angle. That's the same as saying arc tan of x. So that means the same thing. Now when you're doing these problems, you have to know where to look. Okay. For example, let's just crawl over here to the corner. For example, what if I told you I'm thinking of an angle? And what if I told you that the cosine was radical 2 over 2? Okay, so I want you to go backwards. I'm thinking of an angle. You tell me, what angle am I thinking of? Angle has to be the answer. Okay, and you might be thinking to yourself, well, there's two angles. So you have to imagine in your mind a unit circle. The cosine is positive radical 2 over 2 here, but it's also positive radical 2 over 2 down here. So the question is, what's the right answer? There can only be one right answer. So now I have to tell you some rules. Okay, you only are allowed to look in quadrant 1 for cosine inverse, for positives. You can't look down there. Oh yeah, and you have to say all the answers in radian form. So the correct answer for this would be pi over 4. Okay, so what I like to do here is write the rules in terms of some domain pictures. So for sine, you are allowed to look in quadrants 1 and quadrant 4. Okay, look here for positives and here for negatives. You can't say use 1 and 2 because that's positives again. Okay, and what you do is you start at 0. You're allowed to look all the way up to pi over 2, and you're allowed to look down. Down, how do you say a down answer? Negative pi over 2. So the answer has to be written within this domain from negative pi over 2 up to positive pi over 2. In other words, you're allowed to look in quadrant 1 for the positives and 2 for the negatives. All right, let's talk cosine. You have to look in one place. Which quadrant are we going to use for positive cosines? We'll use quadrant 1. Now I need a quadrant for negative cosines. Negative cosines are in quadrants 2 and 3. So do you think I should use 1, skip 2, and then use 3? Well, that doesn't make sense. I'll use 1 for the positives and quadrant 2 for the negatives. So that means you're starting at 0, and you're allowed to look from 0 all the way up to pi. So your answer is going to be between 0 and pi. All right, what about tangent? Where are we going to look for tangent? You need a positive quadrant. Which quadrant will we use to look for the positive tangent answers? 1. They all use 1. And now I need a quadrant for negatives. And the reason that we're going to go with quadrant 4, okay, is because of the graph. I'm going to show you that in just a second. So the answers for tangent, you're allowed to look at 0, and you're allowed to look up all the way to pi over 2. Now, it doesn't make sense that you're allowed to look past all these places. Don't use them and then pick it up. So from 0 up makes sense, and from 0 down to negative pi over 2. So for tangent, your answer is going to be between negative pi over 2 and positive pi over 2. Or what helps some people is just visualizing these quadrants and they know where to look. 1 and 4, 1 and 4. Cosine uses 1 and 2. They all use 1. And the reason for this really is because of the graphs. I need 2 quadrants in a row. Where should I look for positive and negative signs? Sine is the y value. So here sine goes up. From here to here, well, that's more positives. And then I don't want to use them, skip them, so what I'll do is use these negative signs. So what you're doing is you're looking from negative pi over 2 to positive pi over 2. That's why. Cosine, I'll start at 0. Here's some positive cosines, and then here's the negative cosines from 0 to pi. Tangent, it makes sense for me to look from negative pi over 2 up to pi over 2 because it's all continuous here between those. Then there's an asymptote, which is not valid. That's undefined, then more. So that's why we're looking between these values. Okay? Writing these little quadrants on top of the paper does help a lot of people. So when we say we're going to start studying inverses, you have to go backwards. You have to think about which quadrant am I looking in and what's the value. Okay, for example, sine inverse of 1. So I'm trying to find an angle. I'm trying to think of an angle, and the sine value is 1. So that means it's comma 1. And where are we supposed to be looking for sine? Quadrants 1 and 4. But it's positive. So what angle am I thinking of? The angle that I'm thinking of is pi over 2. Okay, so on the unit circle, this is the point, and that's the angle. Remember, your answers always have to be in radians. Okay, answers must be in radians. That's the rule. Okay, in pre-calculus, we're always going to state in radians. Okay, let's do it again. Arcsine is the same as sine inverse of 1/2. So I'm trying to think of an angle where the sine, the second number, is 1/2. Signs that are positive, you can look in 1 and 4, but we're going to put our brain in quadrant 1. What angle am I thinking of where the second value is 1/2? So in your mind, you should be over here somewhere, and you are at pi over 6. So the better that you know the unit circle forwards, the better you're going to be at going backwards. Okay, this is a backwards problem. Cosine inverse of 0. I'm thinking of an angle that's 0 comma something. For cosine, you're allowed to look in 1 and 2. What angle am I thinking of? Yes, pi over 2. Okay, let's practice some more. Remember, inverse means go backwards. What angle am I thinking of? Okay, cosine inverse is negative. You're allowed to look in 1 and 2, so put your brain in quadrant 2. Brain in quadrant 2, that means you're over here. Cosine's the first number. What angle am I at? 3 pi over 4. Okay. Sines. You're allowed to look in 1 and 4. Since it's positive, put your brain in quadrant 1. The sine is the second number. What angle am I at? Pi over 3. Okay, try to close your eyes and do these before I say the answer. Arc cosine means inverse. I'm going backwards. You are supposed to look in quadrants 1 and 2, but it's negative. So where are you going to look? Quadrant 2. Quadrant 2. Negative red 3 over 2 is the first value. What angle am I at? Good. 5 pi over 6. Okay, let's do some more. Tangent is 1. Oh, I love when tangent is 1. It's positive, so you're allowed to look in quadrant 1. What angle am I at? That's our favorite, pi over 4. Okay, oh, this one's going to get a little more interesting. Okay, tangent. Tangent is sine over cosine. So what number can I put down here? You can't put anything. It just has to be a 1. Okay, tangent lets us look in quadrants 1 and 4. 1 and 4, but it's negative. So we're going to look down here in quadrant 4. So the cosine is 1, and the sine is negative radical 3. Can you remember what kind of point has that? I do not see that anywhere. And I kind of see something like that. Okay, so when we did these problems forwards, I told you guys to cancel the over 2 over 2's. So what we're going to do now is we're going to take these values and we're going to divide the top by 2 as long as we divide the bottom by 2. So instead of canceling the 2's, we're going to do over 2 over 2. All right, can you tell me what angle I'm thinking of now? And if you're telling me 5 pi over 3, you're wrong. You're in the right spot. It is 5 pi out of 3, but that's not how you're supposed to say it. Remember, you're supposed to say 0 up or 0 down. So if you start here, that would be down. That would be negative pi over 3. And that is the exact way you have to state the answer. You cannot say 5 pi out of 3. You're only allowed to swing down. Let's go look at that domain restriction again. You have to look up. You have to look down. So anytime you're in quadrant 4, say the answers the same way you would say them for 1, except put a negative on it. Swing down. Okay, let's do another one. Tangent is sine over cosine. And if I do that fun over 2 trick, can you tell me what angle I'm thinking of? Man, I don't remember seeing 3 over 2 ever. So we're going to have to do some more algebra work here. What I'm going to do is say, let's take radical 3 over 3 and unrationalize him. So before he got rationalized, do you know what it was? It was 1 over radical 3. Before he got rationalized. Now, if I do the over 2 trick, and I tell you the sine is 1/2, and the cosine is that, so tangent actually tells you the whole thing. It tells you the cosine and the sine, positive, positive. What angle am I thinking of? Good, pi over 6. Pi over 6. Okay, let's do a couple more down here. Sine inverse of 0. I'm thinking of an angle where the sine, the second number is 0. You're allowed to look in 1 or 4. Where is the sine 0? If you're thinking right here, you are correct, but you cannot swing around and say 2 pi. You have to say 0. You have to be within that domain restriction. You can say 0 up or 0 down. All right, cosine. What angle am I thinking of? You're allowed to look in 1 or 2. The correct answer is right here, pi. Tangent is 0. You can put what number underneath 0? 1. Here's the sine, here's the cosine. You could put a negative 1 too. So I guess it's plus or minus 1 comma 0, but you're only allowed to look in quadrant 1 or 4. I guess we're looking over here, and the right answer would be 0. So let's take a look at a couple of more here. We have sine inverse of a sine. So we have a nested problem. So what we need to do for this is write sine inverse. Okay, and we're going to evaluate that inside angle there. So this is just a forwards problem. Okay, this is just a regular go forwards, think of pi over 6, and tell me the sine. Good, 1/2. Okay, now we're going to do the inverse part. So I'm thinking of an angle, and the sine is 1/2. You're allowed to look in 1 and 4, but this is positive. So where in quadrant 1 is the sine 1/2? Pi over 6. Look at that. All right, let's do it again. Arc sine is the same thing as sine inverse. Okay, and we'll do the inside problem. Now you have to keep writing the outside stuff until you evaluate it. This, I'm just going to evaluate and put the number. I won't put the sign. So swing all the way over to 5 pi over 6 and tell me the sign. 1/2. Okay, now I'm doing an inverse problem. Where is sine 1/2? In quadrant 1, pi over 6. Okay, oh, that's weird. So why did it seem like this problem canceled, but this one didn't seem to cancel? What's different about this one? Pi over 6 stayed, but 5 pi over 6 is not in the domain for sine inverse. Not in the domain for sine inverse. So if you're not within the starting domain, things are not going to just simply cancel out. So please do not go home or come to class tomorrow and say that you've discovered this new fast way where you're just going to cancel things, because that is not always going to work. All right, let's do these two-step problems. Let's do the inside part first. This is just a regular problem. You're going to swing down 2 pi over 3. Tell me the cosine. -1/2. Now, I'm thinking of an angle. You're allowed to look in 1 or 2. Put your brain in quadrant 2. Cosine is -1/2 at 2 pi over 3. Okay, try to think of these before I say the answer if you can. Cosine inverse. All right, first this is forward. Swing down. Swing -pi over 6 and tell me the cosine value there. Radical 3 over 2. Now we'll do an inverse problem. I'm thinking of an angle where the cosine number is radical 3 over 2. What angle am I thinking of? Pi over 6. Let's do a couple more. First we have a cosine. This is just forwards. Okay, so please write the outer part of the problem because we're just going to be evaluating the inside part. At 5 pi over 3, what is the cosine? +1/2. Now, I'm thinking of an angle. Make sure you state it in radians. Put your brain in quadrant 1. Where am I? What angle am I thinking of? Pi over 3. All right, let's do another one. Inverse first. Okay, I'm thinking of an angle. You can think in quadrant 1 or 2 for cosine. Since it's negative, let's think in quadrant 2. The cosine value, the first angle. What angle am I thinking of? 5 pi over 6. Sometimes a little doodle helps people think in the right area. Now, this is just a forwards problem. Go to 5 pi over 6. I know you were just there. And tell me the cosine. -radical 3 over 2. It's okay to do 5 pi over 6 because this is just forwards. Okay, you only have to worry about the domains when it's an inverse. If you don't like arc sine, we can change this to just say sine inverse of 2. Okay, so I'm thinking of an angle where the second number is a 2. What angle am I thinking of? Now, this is not a cosecant problem. This is just a sine problem. What if we think about a sine graph? The spaghetti curve started at 0, goes up, down, down, up. How high did it reach? A value of 1 and as low as -1. When does the sine reach as high as 2? You're right, it doesn't. There's no solution. On the unit circle, the highest value for sine is 1. That was a tricky question. Okay, over here we've got an equation to solve. So before I solve anything, let's divide both sides by 3. So it says sine inverse of x equals pi over 3. And I'm going to put a little note here that I want to see in your notes. This sentence, this equation, is backwards. Okay, that is an inverse equation. What I'm going to do is write this forwards. Okay, here's the same equation forwards. So instead of saying sine inverse, let's say sine of angle pi over 3. Got to switch things around, and that equals answer x. So if you go inverse, the value goes there, the angle goes there. But forwards, the angle goes there. Now, if you guys can just tell me what sine of pi over 3 is, this video can end. Radical 3 over 2. Okay? So what I want you to be able to do, can you state the domains for the three basic trig inverses? Which quadrants do you look in? Sine and tangent both use 1 and 4. Cosine uses 1 and 2. Can you determine the value of a trig function? Using the unit circle, can you go backwards? And can you solve a trigonometric equation that's inverse? Have a good night.